Welcome to the unit on quadratics. In this session, we'll be looking at the discriminant. The objectives for this session are to explore how the discriminant is related to the number of roots of a quadratic and complete related exercises. We begin by looking at the discriminant and especially why it's so important. Now, if y is a member of the real numbers and it's less than 0, then root y is not a member of the real numbers. Notice that there is a square root in the quadratic formula, square root of b squared minus 4ac. For this function, f of x equals ax squared plus bx plus c, with a, b and c being real numbers and a not equal to 0, the expression b squared minus 4ac is called the discriminant. Suppose a is greater than 0 in our quadratic, y equals ax squared plus bx plus c. In order to find the roots of this equation, we use the formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. As we said in the earlier slide, b squared minus 4ac is called the discriminant. When b squared minus 4ac is greater than 0, we have two roots. When b squared minus 4ac equals 0, we have one repeated root. And when b squared minus 4ac is less than 0, we have 0 roots. The case is similar for a less than 0, except the graph looks upside down, so to speak. So let's have a look. When b squared minus 4ac is greater than 0, we have two roots. And again, when we have b squared minus 4ac equals 0, we have one repeated root. And finally, when b squared minus 4ac is less than 0, we have 0 roots. Now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. So if we have that x squared plus kx plus 8 equals 0, then a equals 1, b equals k, and c equals 8. As shown. When the roots are equal, we have that b squared minus 4ac equals 0. Therefore, plugging in the values, b equals k, and 4ac equals 4 times 1 times 8, as shown. So now we can solve for k. Tidying up gives us that k squared equals 32. And square rooting gives us that k equals plus or minus square root of 32. Now for example 2. Pause the video and have a go. Press play when you're ready to view the solution. So in this example, we're required to find the range of values c for which f of x has no real solutions. Now let f of x equal 0. Then we have that a equals 1, b equals 9, and we'll leave c as it is because we have to solve for that. For no roots, b squared minus 4ac is less than 0. And plugging in the values gives us b equals 9 is plugged here, and 4ac is plugged here. And of course, this has to be less than 0. So tidying up, first gives us 81 is less than 4c, and then dividing through by 4 gives us 81 over 4 is less than c, which is equivalent to c is greater than 20 1/4, as shown. So this brings us to the end of this session. If you have understood its contents, you should be able to explore how the discriminant is related to the number of roots of a quadratic and complete the related exercises. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.